Hello and welcome back to this course, covering the exam topics for the JNCIS ENT certification. In this section of the course, we're reviewing OSPF, where we will review OSPF concepts, configurations, and troubleshooting in Junos. In this lesson, we're primarily reviewing OSPF LSA types. OSPF LSAs, or link state advertisements, are the building blocks of information that OSPF uses to populate the link state database, and therefore uses to build a map of the network so it may calculate the best path to each destination. As we learned in a previous lesson, LSAs are simply chunks of data that are contained within an LSU, or a link state update packet, and many LSAs can be contained in a single LSU. Before we take a deeper dive into each LSA type and their purpose, let's do a quick, high-level overview of the LSA types and how the area types affect their flooding. The JNCIS ENT has 6 LSA types that we're concerned with. There are a few more, mostly related to traffic engineering and multicast, though they are not often implemented. These are the 6 primary LSA types that we'll need to be familiar with to understand the operation of OSPF. First, we have a Type 1 LSA, called the Router LSA. This advertisement is generated by every router in an area regardless of their role. The LSA does not leave the area though. An ABR will not flood a Type 1 LSA into another area. To flood the LSA means to forward it, unchanged, out all interfaces except the one it came in on, according to OSPF's flooding rules around broadcast links with a DR and BDR. This is similar with most LSA types, as you can see. The way the information is passed between areas is through the ABR. The ABR, however, will not flood most LSA types between areas. It will originate or generate its own set of LSAs to advertise to the neighboring router in another area. Meaning, though, these LSA types only have area flooding scope, as shown here. The information is still propagated to the other areas, though it is through LSAs that the ABR originates, rather than a flooding of the same LSA. So, a Type 1 LSA is generated by every router. A Type 2 LSA, though, is only generated by a DR of a broadcast domain. This is the network LSA and represents the broadcast segment. Recall that a DR represents the broadcast segment as a pseudonode, which is accomplished through originating a Type 2 LSA. The Type 3 LSA is called a summary LSA. Although the summary LSA doesn't need to actually be an aggregate or summary of multiple other routes. This LSA type is only generated by ABRs. This is the primary LSA type used to propagate routing information between OSPF areas. The Type 4 and Type 5 LSAs are very related in their purposes. The Type 4 LSA is advertised by an ABR and includes the information on how to reach an ASBR, or Autonomous System Boundary Router. Where the Type 4 is used to distribute information on how to reach the ASBR, the Type 5 includes the external destinations that are accessible through the ASBR. Mostly, as long as we're not dealing with an NSSA, the Type 5 LSA is of domain scope, meaning it will be flooded, unchanged, throughout the entire OSPF domain and across area boundaries. Finally, we have the Type 7 LSA. As we learned in another lesson, the Type 7 LSA is only used when external routing information must be distributed into OSPF from a stub area. which must then be configured as an NSSA. Now, although we've covered the OSPF area types in detail in another lesson, let's do a quick refresher on the area types as they pertain to the flooding and originating of LSAs. So, as we've mentioned a few times, the primary reason for the existence of areas in OSPF is to limit the size of the LSDB stored on each router, therefore enhancing the scalability of the protocol. Summarization of routing information can only be done at an ABR, and a single router can be a member of many areas. This table here shows the types of LSAs that are present in each area type. Essentially, 4 area types exist in OSPF. Although the backbone area is always area 0, it behaves in the same manner as a regular area when it comes to the flooding of LSAs. We then have 3 other area types that have increasing restrictions on the types of LSAs that are flooded into each. A more restrictive area would mean that fewer LSAs are flooded into the area, and therefore the LSDB of the routers in that area will be smaller and take less computational power to run the SPF algorithm. As we can see, all LSA types except for the Type 7 LSA are flooded into the backbone and general areas. The Type 7 LSA is a special LSA, which is only used in NSSA areas, though contains the same information as a Type 5 LSA. In order to restrict the size of the LSDB in an area, we can set it as a stub area on the connecting ABR and in all participating routers of the area. A stub area will not see any Type 4 or Type 5 LSAs from the backbone. Since Type 4 and Type 5 LSAs are not allowed in the area, this also means an ASBR cannot be present in the area, as the Type 4 and Type 5 LSAs defining reachability information for the ASBR and the external routes it connects to will not propagate to the other areas in the OSPF domain. Configuring the area as a stub may significantly reduce the size of the LSDB in these areas, depending on your particular network, though you may have a need to restrict the size of the database even further. To accomplish that, we can configure the area as a total stub. This will then prevent the ABR from originating any Type 3 LSAs into the area, except for a default route. All other summary routes will not propagate past the ABR of the total stub area. This would mean that the LSDB of the routers within the total stub area will only contain the Type 1 and 2 LSAs of the routers within the total stub area, and a default route pointing towards the ABRs. And that's it. Since stubs and total stubs are typically small areas, perhaps only containing a single router at a branch office, this will allow the OSPF LSDB of the total stub to be very small and handled by even the lowest performing routers. Let's now review each of these LSA types in a bit more detail. First up is the Type 1 LSA, also called the Router LSA. Every OSPF-speaking router will generate a Type 1 LSA. This LSA describes the subnets that are directly connected to the originating router, and also contains a list of the fully adjacent routers. This means that in a situation where we have a broadcast segment with a DR and BDR present, only the neighbors which are only in the two-way state would not be included in the Type 1 LSA that's generated by each router. Only the DR and BDR maintain a full adjacency with all routers on the broadcast segment and would therefore be included in each of those routers' Type 1 advertisements. The Type 1 LSA that is generated by the DR and BDR, though, would include all of the routers in the broadcast segment since they maintain a full adjacency with all of the routers on the segment. It's important to note that Type 1 LSAs are only flooded within the area. The information in the Type 1 LSA, though, will be regenerated into a Type 3 LSA at an ABR to propagate the reachability information to other areas. Let's move on now to the Type 2 LSA. The Type 2 LSA is also called the Network LSA. These LSAs are only generated by DRs. This means non-broadcast segments, such as links that are manually configured as the point-to-point type, will not have a Type 2 LSA originated, since there will be no DR present on the link. The Type 2 LSA describes all routers that are present on the broadcast segment. This is why broadcast segments are sometimes described as being represented as a pseudonode by the DR. Just like the Type 1 LSAs, the Type 2 LSAs also only have an area flooding scope. This means ABRs will not flood Type 2 LSAs into another area, though they will package the reachability information into a Type 3 to propagate it into another area. Now that we've mentioned Type 3 LSAs a few times, let's take a look at them next. The Type 3 LSA is called the Summary LSA. It's important to note that summary LSAs do not actually summarize routing information such that an aggregate route is advertised to represent smaller contributing routes. The Type 3 LSA will advertise the exact routes as they are. These are just what's used to propagate routing information from Type 1 and 2 LSAs into other areas. These are therefore the inter-area routes. Type 3 LSAs are only generated by ABRs and also only have an area flooding scope. Those are the 3 LSA types that provide OSPF with full internal connectivity. Using just Type 1, 2, and 3 LSAs, an OSPF domain can converge to determine the least cost path from any source to any destination within the OSPF domain. Something that these 3 LSA types don't account for, though, is routing information that is external to the OSPF domain. This would be routes that are redistributed into the OSPF system, and the router that performs the redistribution is called an Autonomous System Boundary Router, or ASBR. Let's take a look at the ASBR Summary LSA, also known as the Type 4 LSA, next. The Type 4 LSAs are originated by an ASBR and describe how to reach the ASBR itself. Since the type of routes advertised by the router are special in that they are external to the OSPF domain, we have a special LSA to describe how to reach this gateway outside the OSPF domain. The Type 4 LSA is actually identical to the Type 1 LSA. It just has a bit set indicating it is an edge router for the OSPF domain. Otherwise, the information described in the LSA is identical to the Type 1. Since the router is an edge device for the OSPF domain, it will originate LSAs describing routes that are external to the OSPF domain. Let's take a look at the LSA which contains that information, the Type 5 LSA. The Type 5 LSAs contain external routing information, which would be routes which have been redistributed into OSPF. The Type 5 LSA is the only LSA we'll be reviewing which has a domain flooding scope. This means that the ABRs between areas will not repackage the information into a Type 3 LSA, but rather will flood the LSA, unchanged, into any regular areas. Note from our earlier discussion that stub total stub, and NSSA areas do not allow Type 5 LSAs, and therefore the ABR will not flood these LSAs into those areas. As we see here, though, when an ABR receives a Type 7 LSA, it will convert it into a Type 5 and flood it into the backbone area. So, let's take a look at that final LSA type next. The Type 7 LSA is generally called the NSSA LSA. See, since stub and total stub areas are not allowed to have Type 5 LSAs, it means we also cannot have any ASBRs in those areas, since the external routing information wouldn't make it past the ABR. If you have a situation where you need to redistribute some external routing information into OSPF from a stub area, then we can use an NSSA area, or not so stubby area. In this case, the ASBR will advertise the external routing information using Type 7 LSAs instead of Type 5. When an ABR receives the Type 7 LSAs on an NSSA area, it will convert the Type 7 to a Type 5 and propagate the information into the other areas, since they now have a domain flooding scope. The Type 7 LSA contains the same information as the Type 5, though was created as a way to allow ASBRs to be present in a stub or total stub area. And that's all the LSA types that the JNCIS is concerned with. There exists other LSA types, though these are generally focused on multicast routing information or traffic engineering and are not covered by the JNCIS ENT. Now, the version of OSPF that we've been discussing over the last several lessons is OSPF version 2, which is exclusively used for IPv4 routing. If you need to carry IPv6 routing information, then we'll need to use OSPF version 3. Before we end off, let's briefly review some details about OSPF v3. In Junos, OSPF v3 is treated as a separate protocol and is configured under a separate hierarchy. As we see here, OSPF v3 is configured in the Edit Protocols OSPF 3 configuration hierarchy. Although OSPF v3 was designed to carry IPv6 unicast routing information, OSPF realms exist which allow OSPF v3 to carry additional address families than just IPv6 unicast routes. OSPF v3 can also carry IPv4 unicast and multicast routing information, as well as the IPv6 multicast information. Further depth and configuration of OSPF v3 is not covered as part of the JNCIS ENT, though, so we'll only need to concern ourselves with OSPF v2. I appreciate you working through the OSPF LSA types with me. I hope that this lesson has been informative for you, and I would like to thank you for viewing.